Alrighty, so today we're looking at Leetcode. Um, just a bit of background for me. I'm a developer for one of the FAAMG companies, um, and gets have some experience with the whole interview process. In the future, I'll probably do some recommendations around how to prep for that. But guess really kind of wanted to look at problems in a couple of different ways, see if I could still do the leak code. I guess also give people some insight in how Fang developers go about solving their problems on leak code. Um, just for kind of some specifics for how I would be looking at problems. Really, there's two types of things we want to be looking for. Really, it's either an array problem or it's a tree problem. Those are probably 90% of interview problem. I guess also some type of like hash map problem to make a more optimal solution. But those are kind of your typical categories. Hash map's kind of like a subset of each of those. But um, anyways, from there, let's look at today's problem and see how we can go about kind of solving this and then looking at it a couple, higher steps. So right now we just got a very basic method that's empty. It looks like what we're doing is we're looking at comparing two versions that are split by a dot, and there might be leading zeros, and revisions are zero left or right. So what I think this is saying is we can look down here is we have two version numbers that are coming in. We have a 1.0 and a 1.1. And what we're trying to determine is if this version 1 is less than version 2 or vice versa. And essentially, like you can kind of think of a couple of use cases for this. This is a very typical like method override for comparing two classes. The other use case would be like let's say you work in some type of builder tools for your company and you want to check if like package 1 is less than package 2 to tell people to pick up the new package. This would be some type of builder tool that does a similar thing to that in there. So let's start going about this in my kind of initial brute force kind of way. So what I'm thinking is we're gonna take these as an array and kind of parse them into, or sorry, take this as a string and parse it into an array. So we'll have a string array. Let's just call it version 1, and that's going to be equal to version 1 dot split, and we'll split on the period, and we'll do string array version 2 equals version 2 dot split on the period. And where did that parentheses come from? Okay. And what we're gonna do is we're gonna loop over these two. Why does why did this go down here? I don't like that. All right. So what we're gonna do is we're gonna do a for loop. Where int I equals 0, I less than. What are we looping? We're looping to. We need one more variable. We're gonna want to do a int maximal length, and for this we're gonna do the max of b1 dot length. Is it? No, wait, no, it's an array, so you don't do the parentheses. It's actually a property, and now I have the muscle memory to do it wrong. All right, so we're gonna do loop over to the max length of each of these, and we're gonna go all the way increment by 1. And what we're saying, so get to we're going to loop over 2, 0, 5, 1, and then we go to the 3, 3 spot. We still want to get into that 3, 3 spot, but that means we're going to need to do some edge case checking. So what we want to do is essentially something like int num1 equals b1 of I. Now, for the example we just said, we're going to have to first do a check on that. And we're going to check if our current index is less than the length of its array. Or, yeah, of its array or of the original version string. Make sure we're not at the last, or at a number over what this was able to parse into. And what we can say is if it is less than it, then let's cast this to a integer. And if it's not, we'll just treat it as 0. And the reason we can treat it as 0 is if we look at this 2533 and the 0, 1, let's say we had 2533 and 25. We want 25 to be considered 250, right? And that's what we're doing here. We're saying if it's a number that would go over, then treat it as 0. And we can copy this over to our num2 calculation. And num2 is just going to be the same thing as number 1, but with 2. Let's kind of just think this over. And then I'm going to add just 2 print lines to make sure that we haven't goofed up any code yet. This is just kind of like a syntax check before we get too far. Heads up, if you're doing an actual interview, they're not going to really care about syntax. They probably don't even know the language you're doing. And then just to make this compile, let's just return 0 by default. And we're going to want that as the initial thing anyway. So let's run, see what happens. It doesn't like our return. Oh, because why doesn't it? Oh, because I'm not in the correct parentheses. Oh, have the wrong thing copy pasted. It helps when you put your return in the method. Just a fun fact. So what does it not like? B1. Helps when you spell length correctly. And it looks like so two cases were passing off the bat because they were tied. You know, you got that O of 1 runtime of just skip the entire method and just return 0, right? And you're right. You know, you figured 33% of the time. Actually, if you think about it in our use case with like the builder versions, like people are less likely to be upgrading package and just keep the same package version. So if you return 0, you know, you're probably right like 95% of the time. And but all right. So looks like that, and then what was our output? Did we not get a? Why didn't it print for us? Let me check what max length is to make sure we're actually going into our for loop. Interesting. So you know what it is? We gotta do escape characters to make so it actually parse. All right, that should fix it. All right, let's double check. Run. There we go. All right, the world makes sense again. You can't parse on just a period. You have to parse on the escaped period. All right, things make sense again. Okay, so now let's do our actual return logic. And what we're gonna say is in our for loop. And I'm assuming, yeah, so they say if version 1 is less, return a -1. If version 2 is less, return 1. So if num1, so if the first digit we find is less than num2, let's return that -1. And else if num1 is greater than num2, return 1. And otherwise they're equal and we continue, and if we get to the very end and every number is equal, we return 0. So let's check this, and this should work for our very basic implementation, and let's see if it meets all the test cases. Ah, cool. So we are passing. Now it seems like there's some optimization stuff that we can do. Because the way I kind of think about it is if you see two chunks, especially on these like short time ones, means there's a way to make it better. So let's think about some ways we can make this potentially more optimal. I think the first thing we can do, and it might be the only thing we can do, is instead of doing any pre-processing, we could loop over, do like a two pointer approach, and that would save us these function calls, these split calls. That's how much time? We're working at like 1 millisecond of optimization, so that actually might be it. Is that instead of doing our loop over an array approach, is we do like a two-pointer approach. So when I say two-pointer, what do I mean? So what we can do is let's have an int I equals 0, j equals 0, and an int um, like num1 equals version1 dot length. And this time, because we're doing it on the string itself, we have to do the parentheses rather than up here where it was on the array. 2 equals version2 dot length. And what we're going to do is instead of doing our for loop logic, we're going to say while I is less than number 1 or j is less than number 2. And what we're saying here is we're looping over the different spots in these strings directly rather than looping over an array. And what are we going to do in these? Well, we're going to then have back our solution from last time, so the actual full one. So let's actually rename these like max1 and max2, max22. Um, and that way we just have better variable names. So we're going to have int num1 equals 0, num2 equals 0. And what are we going to do? So let's comment out our fork loop again. And we're not going to be using that. We might use this. We'll see. So what are we going to do? Well, now what we need to do is check. We need to get the number in each of these. So while I is less than our max and the version 1 charet, if we're not at a period, is essentially what we're about to say. So if while we're looping over the string, does it have, here, let's go to the one that has a couple numbers in it. While we're looping over this, we're saying, let's imagine the 001 was first, and let's just look at this part. We're going to loop over it, and we're going to say we're not at the max, and we're not at a period. So imagine that it's like a 0.0 at the end. What are we doing? Well, we need to do kind of like something like the very typical, like essentially reading a string and converting it to an int kind of thing, where we're going to like increment a tens digit kind of thing. So we're going to say num1 is equal to num1 times 10, and we're going to increment by, this is just going to be the parsin again, right? Where was my original code for how we did that? Integer.parseInt. I don't think we can do this anymore. Does this work on strings? No, because it's gonna be a string, so now we have to do it a little bit differently, don't we? Because before this was like a whole number. So what we could do is the very fancy converting the string or the character to an integer. If you know it's an integer, what you can do is the character at I and subtract it from the character 0. And what this does is essentially, this is the equivalent of saying like character 1 minus character 0 equals 1. And what are we going to do with this? Well, we're going to then increment I. And that means we're going to another value over. And we essentially need to do this exact same logic on the J. So while J is less, oh, it wasn't max and 1, it was max 1. And this is now max 2. And version 2, char at J is less than our period, and then we're gonna do number 2 equals number 2 times 10 version 2 char at J, and do the same thing here. I'm gonna keep this in for 1 just to keep stuff kind of clean. And what can we do from here? Well, I think we can still do our exact same return from our old logic. Because what we're going to have is we're going to keep going until we actually get the full number. So you can imagine if it's like 101, we're going to keep incrementing over this. We're going to start with it's 0 times 10 is 0 plus that 1, increment it. So now it's going to be 1 times 10, 10 plus 0 is 0, so 10. 10 times, let's just kind of think about it right now. If we have like 101.0. So we would have 1, then we would have 10, and then we'd have 100 plus 1 to get 101, and that is correct for how we want to think about that. And let's say the other one is like, down here, 100.0. We can check if 101 is greater or less than 100 and return that way. And that's essentially what we already had down here, I believe. And we should be able to use our exact same return from before. So let's see how this runs. See if we have any syntax mistakes. We got some type of syntax. Oh, because we have this down here. All right, we can get rid of this code. We have an extra parentheses, it looks like. Let's check now. Time limit exceeded. So we did not increase our runtime this way. Let's think about oh, helps when you increment the right thing, right? We're still taking a while. We still have something wrong somewhere. Let's figure out why. So while I is less than the max of the first one, or j is less than the max of the second one, we initialize our two values, and then we'll always say while I is less than the max of first, and version 1 char at I not equal to period. This should be doing correctly. J is less than max 2 and version 2 char j not equal to period. J plus plus. I don't see. We have one more thing is we keep getting stuck at the period. So we need one more iterative thing down here, don't we? Because what's happening is we're getting to the period and then never moving over the period. Oh, this should fix it. There we go. So case 1, 2, 3 passed. Let's see how our runtime's doing with this. And we finally got over to our 0 millisecond. Beats 100%. That's the goal. And we're doing good. So let's just clean up our code really quick just to make it a little bit prettier and talk through one more time. There we go. So what we're doing is we're doing like a two-pointer approach to the strings. We're iterating over each of the strings and using that to create our version number for that particular, let's call it a partition. We're essentially saying every number that's split by the periods is its own partition of these version strings. So what we're doing is we're looping over each number to get its partition number and getting a value from that. If we can't determine a value, we default to 0. For each of those partitions, we can go in order and determine if the first or the second one is bigger and return based on that. And then we just keep going until we have um, either one value being greater or less than the other, or we get to the end, and in which case, if we get to the end, that means they're both equal. So that's how I'd solve this problem. Let me know your guys' thoughts. Have a good one.